Welcome to the Lionheart Academy. My name is Richard Tai. Today, this is our 10th lesson for trigonometry, and let's go ahead and continue talking about functions of acute angles. Now, there are actually a lot of things going on in right triangle trigonometry, so this is why we're spending several lessons here. Continue talking about the little details of right triangle trigonometry. Alright, so let's go ahead and start with looking at the right triangle here. Our triangle ABC again. Angle A and angle B are the acute angles, and angle C is the right angle. And the relationship, let's just review briefly. Angle A and angle B, they add up to 90 degrees. They're complementary. The key words here is complementary. Angle A and angle B are complementary. Alright, it's going to be side A, this is going to be side B, this is going to be side C, which is opposite to angle C. So side A and side B are the legs of the right triangle, and side C is the hypotenuse of the right triangle. Alright, so today we're going to talk about reciprocal functions and the relationship between the functions. So let's take a look at sine of angle A. If you remember the acronym for SOHCAHTOA, remember SLHCAHTOA, SOHCAHTOA, okay? So the sine of angle A is going to be the opposite leg over hypotenuse, which is A over C, and then the cosine of angle A is going to be the adjacent leg over the hypotenuse, and tangent of the angle A is going to be the opposite leg over the adjacent leg, A over B. Okay. Now, what about the other three? Secant A is going to be the hypotenuse over the adjacent leg, and cosecant A is going to be equal to the hypotenuse over the opposite leg, and cotangent A is going to be equal to the adjacent leg over the hypotenuse leg. So let's take a look at this. Let's look at this a little bit closer. As you can see, there are three pairs of reciprocals. Reciprocals means they're not inverse of each other, but they're flipped. If you look at the fraction, the numerator and denominator are opposite. So as you can see, sine A and cosecant A, they are reciprocals. Right? Sine A is A over C, cosecant A is C over A. Okay, and cosine A and secant A, they are reciprocals. As you can see, cosecant A is B over C, secant A is C over B. Alright? So they are reciprocals. And of course, tangent A and cotangent A, they are reciprocals. So it's very important to understand which are the pairs of reciprocals. So let me go ahead and write that down for you. Now we need to go ahead. So the reciprocal functions, okay, and that will always be true. That will always be true, which doesn't matter which angle they are. So sine A and cosecant A are reciprocals. This is a very important fact that you need to remember. Cosine A is always reciprocal of secant A. Okay. Now let me actually write using mathematical formulas. Okay. What do I mean by reciprocals? It means when I multiply them together, their product is always equal to 1. Their product is always equal to 1. Okay, so let me actually write it using the mathematical formulas. So that means sine A times cosecant A is always equal to 1. Okay, so sine A times cosecant A will always equal to 1, or it means that sine A is the reciprocal, which is 1 over cosecant A, or cosecant A is equal to 1 over sine A. So that's what that means. This is what it means mathematically to be reciprocals of each other. Okay, to be reciprocals of each other. Now cosine is the reciprocal of secant, so cosine times secant will always be equal to 1. So cosine of the angle A times cosecant of the angle A will always be equal to angle 1. So that means cosine is always going to be 1 divided by secant A. Okay, 1 over secant A is always going to be cosine A, and then secant and angle A will always be equal to 1 over cosine A. So this gives us a very useful relationship. This three sentences give us a very, very useful relationship between cosine, secant, sine, and cosecant. And the last one is tangent and cotangent. Okay, tangent and cotangent, they're cofunctions, but they're also reciprocal functions, which is what we're going to talk about next, cofunctions. functions. Okay, sine, cosine A. Let's see. So tangent is equal to the reciprocal of cotangent, which is 1 over cotangent, and cotangent will be the reciprocal of tangent, is 1 over tangent. All right. So when you divide both sides, when you divide 1 by tangent A, you get cotangent. When you divide 1 by cosine, you get secant. When you divide by 1 by sine, you get cosecant. So if you know the sine of an angle, you automatically know the cosecant of the angle. If you know the cosine of the angle, you automatically know the secant of the angle. If you know tangent of the angle, you automatically know the cotangent of the angle. That's why if you know this 3, sine, cosine, tangent, you can find out secant, cosecant, and cotangent. Vice versa. If you know secant, cosecant, cotangent, you can find out sine, cosine, and tangent. Okay? So this is a very important relationship that we will explore a little bit later down the road. They're called reciprocal functions. Okay, let's move on to another important relationship called cofunctions. Okay, cofunctions. While we talk about cofunctions, right? The word cofunction means together. Okay, and there's 3 sets of cofunctions: sine, cosine, secant, cosecant, tangent, cotangent. They are called cofunctions. Well, let's examine the cofunctions. But first of all, again, let's remember angle A and angle B, right? Measurement of angle A plus measurement of angle B is equal to 90 degrees. They are complementary. So angle A and angle B are complementary. Complementary. Again, complementary means they add up to 90 degrees. Okay. Alright, let's go ahead and consider angle A and angle B and consider their sine value and cosine value. So we're going to do it very quickly. So let's take a look at sine A. It's going to be A over C. Cosine A is going to be B over C. Tangent A is going to be equal to A over B. Okay. And secant A, angle A is going to be C over B. Cosecant A is going to be C over A, and cotangent A is going to be equal to B over A. Okay, so let's look at sine B. Alright, now keep in mind angle A and angle B has a certain relationship. They are complementary of each other. So sine angle B, if we go ahead and look at angle B here, is sine B is opposite, which is sine B over C. Okay, its cosine B is going to be equal to adjacent A over C. Its tangent is going to be opposite, which is B over A, right? And the secant value of B, secant of angle B, will be C over A. Cosecant B will be C over opposite, which is sine B, and then cotangent B will be equal to A over B, opposite over adjacent A over B. Right, so let's go ahead and examine the 2 sets of values to see if we can see is there any relationship here. Well, I see that sine A and sine B, they're different, but sine A and cosine B, they're the same. Do you see that? I'm going to draw arrows. You see sine A and sine B are the same. Cosine A and sine B, they are the same. Okay. Tangent A and tangent B, of course, they are different, but tangent A and cotangent B, they are the same. They're cofunctions. They're the same. Okay. Cotangent A and cotangent and tangent. This is cotangent A and tangent B. Okay, I made a mistake here. This one should be tangent B. They are the same, right? And we have another pair of you see that secant A and cosecant B. That's very light. I'm sorry, that's too light. Let me use black here. Secant A and cosecant B are the same. Cosecant A and secant B are the same. So what does that tell us? Well, this tells us that for complementary angles, their cofunction values are the same. Okay, the cofunction values are the same for their complementary angles. You see, measurement angle B is equal to 90 degrees minus angle A, right? Minus measurement of angle A. minus measurement of angle A. So they're related in such a way they're complementary. And when they're complementary, their cofunction values are the same. So let's go ahead and write out several sentences to see if we can draw a conclusion here. So that means cosine of angle A is equal to sine of angle B, but sine angle B is 90 degrees minus angle A, so it's 90 degrees minus measurement of angle A. That means this will apply to all acute angles. It will apply to all acute angle. Okay, so the sine of angle A will be equal to cosine of 90 degrees minus measurement of angle A. Okay, that's cosine. That stands for angle B, and so this tangent angle A will be equal to cotangent of 90 degrees minus measurement angle A. I'll give you some examples after this. And cotangent of angle A will be equal to tangent of 90 degrees minus measurement of angle A. Okay, and so the secant and cosecant. So secant A is going to be equal to cosecant of 90 degrees minus measurement of angle A. Okay, and cosecant of angle A will be equal to secant of 90 degrees minus measurement of angle A. Alright, so for example, if angle A is equal to If angle A is equal to 62 degrees, that means measurement angle B will be equal to 90 degrees minus 62 degrees. So that will give us 28 degrees, right? Okay. So 62 degrees, 28 degrees. I don't need to know what the sine value are, but that exactly what sine of 62. But I know sine of 62 will be equal to cosine of 28 because they are cofunctions and they are complementary angles. So cofunctions works with complementary angles. So if I say cosine of 28, or now I say cosine of 62, that will have to be equal to sine of 28. Okay, and if tangent of 62 degrees will have to be equal to cotangent of 28 degrees. And cotangent of 62 degrees has to be equal to tangent of 28 degrees. And secant of 62 degrees has to be equal to cosecant of 28 degrees. Alright, and cosecant of 62 degrees has to be equal to secant of 28 degrees. So as you can see, the pattern stays for all kinds of complementary angles. As long as they are acute and they are complementary, then that's what's going to happen. Alright. Okay. Okay. So let's take a look at another example here. So what is sine of 29 degrees, for example? Let's go ahead and express this using this cofunction. Well, we know 29 degrees is complementary angle is 61 degrees. So sine of 29 would be equal to cosine of 61. What about cosine of 22 degrees? Well, cosine of 22 degrees I can express using the functions of complementary angle. It will be sine of 68 degrees. Okay. What about cotangent of 35 degrees? Well, cotangent of 35 degrees should be equal to tangent of, let's see, what, 65 degrees? No, actually it's 55 degrees. Yeah, 55 degrees. Okay. And then, let's see, let's try another one. What about secant of 80 degrees? Well, secant of 80 degrees is going to be equal to cosecant of 10 degrees because 80 plus 10 is 90. So it's very simple procedure. Just determine the complementary angle, and you'll be able to express the angle as cofunction of its complementary angle. The cofunction of its complementary angle. Okay. All right.